building, and I don't know that I see any wireless access points nearby. So this is a good test.
Well, the video quality is not bad.
Okay. Okay, so
we can tell it's a door in front of you.
Yeah, let's walk in, and students can request access on these key cards, and I am going into our lab. This is Mo Hosni's territory, and this is alien territory for me, but let's start over here. I walked into the lab, and the first thing that you're going to see are, on the one side, our safety equipment, the PPE, and then on the other side, you've got the SDS sheets. You've got a fire extinguisher that, we have regular inspections. And this particular room, I'm going to do, yes, sir.
Go back to the fire extinguisher, please. And
yes, sir.
Keep on the inspection sheet, and I wanted to see the date. Okay.
And it says we inspected 2019 December. So you can see 2019 down here, and December is when we punched it out.
2023. I got everything I needed. Thank you, sir.
Okay, sir. So I'm going to swing around the room once because you had asked to see a general layout of the lab, and then we'll look at some equipment.
Right.
This is about a 1,200 square foot laboratory. We've got a whiteboard at the front with projection equipment. Right. This is used to support the area of thermofluids, and we've got a range of equipment across this lab.
Just a little bit slower, please.
Okay, so let's start our walk over here. And Dr. Hosni, this is your space. I have absolutely no idea what I'm doing. So I'm going to tell you that this is bathtub number 1.
Right.
And so we've got, this lab is primarily, tech equipment, instrumentation that supports 4 or 5 courses in the ME program. And so we've got students that are in here at any given point in time. You may have a couple of students at each one of these stations, and sometimes they're designing the experiment, sometimes they are, following something that is a little bit more prescribed, and that depends on, who or what course they're taking. So you've got a little bit of you've got the hydrostatic bench over here.
Yes.
And another one of these tanks.
Right.
Interestingly enough, the environmental science students also come in here. We do a lot of interdisciplinary work, and it might, help you and Dr. Odshorn, who lived in Texas, to know that these flow channels, the flow channel that we have here has sometimes been used to model things that happen at the coast not far from us.
Yeah. How far will a tsunami or a storm surge go across into Brownsville, Texas when it hits the coast off South Padre Island?
There you go. And for us, it's Mustang Island and Port Aransas and Rockport that is a little bit closer. We've got, centrifugal pump set up over here.
Right.
And then as we swing around, we've got some, convection equipment.
Yes.
Walking through some instrumentation setups for thermal conductivity. A little bit of a test, engine setup over here.
Yes.
And then a heat exchanger module. So one of the things that had happened at the
Go
end
back to the engine model, and I wanted to see the floor, to see what is on the floor. Could you move back a little bit?
Sure.
Good. Looks good, looks clean, everything is nice. Excellent.
Now, one of the things that we had on the last ABET visit, it wasn't identified as a shortcoming. It was identified as something that we should look at, and that was connection. We had at some point the need to drain tanks, right? You've got these tanks that needed to be drained. And what had been identified by the previous team chair, who Herb Rayborn, who comes out of industry, pointed out that having hoses on the floor was not good.
Right.
So alerted us to potential backflow issues.
Good.
So what we ended up doing is we ran a quick project, and you can see this PVC piping all around.
Yes. PVC
So
pipe.
what we ended up doing is we ended up collecting all of that water, and we tapped it into the drain over here.
Sure.
And so, that has been, pretty good fix, and we've not had any leaks.
All right.
First aid kit.
Winston,
Yes, sir.
let's not use anybody's name because this might be something that we want to use as a sample for the team chairs. So looks good.
Sure. So when we do the next lab, I'm going to have it maintained without names, and that will take us through. So
I wanted to
another
see
heat.
the tunnel that you showed when you walked in. Could you go back to the wind tunnel behind you?
Yeah, absolutely. So we've got a subsonic wind tunnel over here,
Right.
Flowtech wind tunnel that we have different students using.
All right.
I'm seeing one thing that is out of order that we'll need to relocate. That rag doesn't belong there.
Well, that's okay. And I would like to see the exit of that wind tunnel to see the front has the honeycomb pulling the air through, and probably the end is where the fan is. So where is the fan?
Walking over here,
Good, good. And
around.
here's the fan, beautiful. And that is fantastic. You pass because this has a cage around it. So as it pulls the air through, any pieces of the experiment that might get loose is going to get trapped and is not going to hit anybody. So this is a very secure one. Excellent. Happy with that. Thank you.
Good deal. And so we are going to now walk out of the thermofluids lab. Hopefully the equipment that you saw in criterion 7 in the self-study matches this. We do have detailed spec sheets that we can share with you if needed. I'm going to go ahead and kill this and walk out, make sure it's secure. We do have a storage area in front of us, nothing particularly exciting there. And, the constant signage over here, if you're wondering about these signs, this is the posted policy that we have for extended access to our labs.
Could you hold it for a
And
second? Hold it for a second. You're right there. Okay. I wanted to see if I can read it, and I can. So as long as it kept there, then everything is very clear. Thank you.
so students have to petition the faculty member, and then you also have the associate dean for facilities and operations is the one who approves the, getting into the labs. Because this key card system is tied to our banner system, we can grant and revoke privileges either by class or by individual. So this was about a $40,000 investment that was made a couple of years ago from the dean's office to grant, much broader access. This is our materials and testing laboratory, and it is used to support classes like, statics and strength of materials, materials science. We also bring in our physics students in here because we don't want students to see these things for the first time in, say, a manufacturing processes class. They should have seen stress, strain, curves and modulus of elasticity and resilience and toughness much earlier. So we are going to go ahead and access the lab.
So
And
I've got 10 minutes till the next Zoom meeting.
Sure
So
thing.
we would love
So
to
we
see.
will,
Your video just froze
the
again.
broad layout, the lab is set up for about 12 to 15 students. One side of the lab is set up for, some of the mechanical testing. So we've got an impact tester in here. And this is Instron. And then over here we have an MTS Tensile, universal testing machine. And you can see both the machine, and if I get in a little bit closer, you should be able to see the extensometer for this piece of equipment. We've got a range of different grips so that we can work with different ASTM specimens.
Okay,
And,
hold on. Okay, I would like to see the shield for that. Is there a shield on that?
So right here is the shield for the machine.
Got it.
So
It's not clear.
the machine is shielded on all four sides and the top for this particular instrument. For the impact tester as well, there's a shield on all four sides and the top as well. If I step back, you will be able to see that. And this is interlocked, okay, as you can see. This is when the machine is running, when a test is running and the machine's powered up, you will not be able to open this. Well, you can open the door, but it is locked. You'd have to break the lock to be able to open it.
I saw the shield on that one. I couldn't see the one on the Instron machine. That's why I asked.
Yeah, that was actually pretty nicely cleaned, which, is something that we like to do. A little bit of a rotating beam fatigue test machine over here. And then we've got, I'm not going to pull the shroud off, but if you, this is a, Wilson hardness tester. And then on this side of the lab, we do a little bit of optical metallography. So, we have the sink with different things plumbed in here. A couple of different saws. We've got a coarse saw and a wafering saw. And once our students cut their specimens, they are able to come to one of these two mounting presses. So if we need to do something, the next step obviously is going to be mounting in Bakelite. And then we do have an automated polishing and lapping apparatus over here so specimens can be prepped and polished. One of many furnaces that are scattered in different places. There was a little bit of a student project going on in here. Interestingly enough, we've been working a little bit with some of these, standard specifications. So students have access to all of those. And then we've got 3 of these inverted microscopes.
Winston, question.
Yes, sir.
Could you go back to your oven? Is it hooded? How is it connected?
So this particular oven is not hooded, and connection for us is a standard 115.
Understand. So let me ask a question. Could you move it back a little bit so I can see the whole thing? Yeah, so good. All right, so if you put a specimen in this oven and something burns, of course it gets hot, where does the fume goes? And does the room has ventilation system to take that fume out?
So we do have a ventilation in the room, and you can see the part of the air handling, but there is not a hood above this particular furnace.
Okay, good.
I'm not sure how hot it gets. That's a good question. So that's something for us to follow up on. So 3 different microscopes. I see 2 of them out here. The third one's probably sitting aside someplace. And then we also have a dynamic machine analyzer in here. And I'm not sure who the last user is or was, but there's an experiment currently underway. And I don't know if you can look inside the little window
Okay,
without.
you see that? That looks good. Right next to the machine, could you please put your camera on the extension cord? Okay, well, this does not have any kind of fire breakers or anything, so
That might be on the outlet.
unless the outlet itself has some kind of circuit breaker built into it, this could be something to look into for the extension cord. And normally the safety folks don't like extension cords in the lab, especially that does not have automatic circuit breaker on.
Yeah, that's a good point. I think I'm going to ask the program chair and the lab folks, because this is something that I'm hoping we would pick up on a summer safety walkthrough. So every year we walk through the labs.
Most of the PVs are not as nosy as I am, but I do apologize. I'm just kind of curious about things, and I do ask about it. So thank you for telling me that.
You know, you're evaluating the mechanical engineering program over here, so we want to make sure that we are compliant with, the APPM and the facilities being safe. So I will tell you that this is something I'll take back to my chair, and the program chair and the faculty can address this. So this is really helpful feedback, as the team evaluates our facilities.
Everything looks great. Thank you.
Okay, so I am going to go ahead and shut this down, and I'm not sure how long that particular lab tour took, but I appreciate the help